So let's continue on I wouldn't say I promised. I hope I wasn't too ambitious, but I promised that I brought up this idea that we could skip regex. Right? We are at the tokenization step where we are getting our tokens. Right? We would possibly see how we could do this without a regular expression. How to build our own engine, basically. Right? And actually, it's not that complicated. Right? Well. Depends on your definition of what complicated is, but so I'll show you the idea of using your own finite state machine, right? And what's a finite state machine? Well, again, I'll refer you to Wikipedia, which is, in this case, something like this, right? So, it's not a Turing machine, right? Second level, right? Again, just enough for tokenization, certainly enough, right? So here's an example, right? Simplest example, you have two states, so you have states and transitions, right? So this example is of a turnstile when you're going to like in some concert or some arena, so some closed space, right? You push a coin and you do something. So this very simple finite state machine, you have starting, you assume it's starting, right? And then you put the coins unlocked. If you push, right, it goes back to locked. So only one person can pass through. So who can tell me the problem with this finite state machine?
There is no ending state.
Well, there's no ending state. It's a for, of course, no. But that's well, maybe that's, you know, you want leads forever. But what I personally don't like about this machine, if I'm the user of this machine, do you see the problem?
You don't get back the coin?
Yeah. You can keep entering coin. You unlock it, and you start. If you for some reason you have a brain something, right, and you keep adding coins, you will not get it back, right? It'll stay unlocked, right? It shouldn't really accept coins, right? It should go in some other state, right? Again, of course, to make it will get more complex, right? So this finite state machine is will take all your coins happily, right? Right. I suppose you can make it more evil. If you put second coin, it goes back to lock, right? It'll be really evil, right? Yeah, you put one coin unlocks, next one unlocks, right?
It's a punishment.
Yes.
For the user.
For your stupidity, right? Basically, you put too much coin, you lock yourself, right? So, but okay, but hopefully, so the two things you have this idea of acceptance states, right? And you have a starting state, basically, right? You obviously start somewhere, right? At some state, right? And then you start, you do these transitions to different state, basically, right? So you have these moves, possible moves, right? And again, so I will make it something like, I'll draw again, right? So you have some starting state. And let's say I want to do something simple, like I want to accept things like, 5 plus, for now just single digit numbers. Let's go with that really simple tokenizer, right? So on, 8 minus 6 plus 3 is okay, right? Something like that, right? So, or, 9 minus 1 plus 3 minus 6 minus 2, and so on, right? For now, let's build a really simple finite state machine for something like this. How will it work? Right. So, if you have nothing, right, also, do we want to accept, we have defined what's we want to say, is this, so these will be okay, right? So these okay, right? Okay, right? And like 5 plus, not okay, right? Not okay, not okay. And we spoke of this last time, right? And what else is not okay? Questions, what do we do with this 5 times 7.5, right? Do we let it slide? We don't, right? This is not going to be not okay, right? Right. Of course, what we could do is, if we have certain symbols like, for example, multiplication, right? You can just ignore them. It's up to us how we want to define this, right? So these are the rules. How could we make this really simple machine? Let me see what kind of color I'll say. I guess I'll just use black for now, or maybe I'll use something else, like, I don't know. Right, so you have some starting point. So I guess if you use starting point, so this is nothing, you know, nothing, empty, 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 empty is okay, right? So let's allow empty okay. So we have starting state, and we can say, okay, this is okay, right? Start. Right, and then we start getting moves, right? So, and again, since this gets very complex, I'll just say digit. So we have, what kind of moves we have? Anything else? So, stuff starts coming in, right? We're starting to parse, right? Running this program, what to come in? Digit, right? Operator, right? OP, right? And what else? OP, which is minus, right? And everything else, other, right? Right. So let's do this. If you're getting junk, let's ignore everything else, right? The question is, of course, how strict do we want to be, right? If you're getting junk, right? We have a fail basically, right? So we could go, if you get anything, well, we have white space, which we ignore, right? Other and white space, so let's assume white space is okay. White space. White space, right? Other would be fail, right? This would be fail, right? If you get like V or Valdis or RB or any other character, right? Non-white space, fail. Come on, red. Ah, this one here is red. Come on. Fail, right? Fail, right? And that's it. And you can't get out of this, you know, we fail. So this will be our fail, catch all fail place, right? So, digits okay. So, we could go to new state. We go to digits. I'll call this digit state, right? Digit state, yeah. Have digit, right? And OP, again, if by now you realize OP also goes to fail because plus or minus is not allowed, right? If we get a plus or minus at the beginning, we fail. Again, we'll keep things simple. So digit is fine, right? So single digit is fine. Is this allowable? Yes, right? Single digit is allowable, so we'll make it mark it as accepted. So we have multiple acceptance states, right? So digit, have digit. Digit last. I'll call digit last. And again, we can do again other fail, right? White space, right? White space on, what do we need? So we can also do digit. We assume we don't allow second digit, right? You can see how we could add more digits here, right? Very easy, right? Here we could add more digits, support for 5,000 digits here. Trivially, we could just keep adding here, right? But for now, we'll just fail on digits, right? We could move it afterwards. And now, what we need, only way we can do is we need OP, right? OP, operation, right? OP last, right? And again, is this acceptable? No, it's not acceptable. But plus and minus, we need to do something else. So we're not finished. Right? So OP last, and so it's not accepted, right? These are fine, but this is not accepted. And then of course, digit last, right? So again, digit, right? You can see here, and we're almost done, right? We can say everything else goes to fail, right? Other, right? And white space, you know, like this. And I think white space I can't type, right? So digit last is how we end, right? Can we go to start? Well, you can see how we could possibly. We didn't really need all of this, right? We could have skipped the start. We could have started here already, you know. But so this extras, you know, when you draw these finite state diagrams, you could have skipped the start, you know, maybe go directly to start, right? Because we have sometimes some variations you only allow one acceptable state, right? You can do transformations like that, but here it's very convenient. You have two accepted states. We have fail state and OP last. So once you get to fail, there's no way to go out. Let's see. So, kind of similar to what we did in where is my turnstile? Right here, right? Right? With only two states, but similar idea, really. Right? So, and this will parse, this will check your syntax, right? Instead of regular expression for digits, right? And you can imagine that you, in these transition states, right, you could add some sort of storage, right? You can store stuff, right? Push like some stack-based approach or maybe some other approach, right? You can store your operators, you can store your digits as well, right? If you need to store them, right? Because, of course, in this case, since, because we assume we're going to do this afterwards, later on, right? So similar approach would be for something, you know, you want to add the parenthesis, support for parentheses, you want to add support for multiplication, division, and so on, right? So, again, this is not, does not perform the actual calculation, this just checks the syntax at this stage, right? So, hopefully you saw this idea, right? So, let's do this, so let's see if we can quickly do this in our code. I don't know if we'll be able to do this, right? So, yeah. So let's create the tokenizer. Yeah. Well, yeah, that will use finite state machine to tokenize our expression. Let's do this. 3 states: number, operator, another. Let's see. That's enough. Yeah. Now, but how about parentheses? We want to support parentheses. Yeah, and numbers. Okay. And integers. Okay. Yeah. Okay. Okay. Since now it starts hallucinating. Code spaces now. So we will have states for it. So we'll have a current state, right? And we have transitions. Yeah, right? So that's the basic idea. Dictionary, let's do dictionary transition. That's probably easiest, right? On final state, right? Dictionary token, right? Dictionary token values. Let's see, this is maybe going too far, right? Let's do this. Yeah. Function takes a string that translates tokens. Or if the tokens values. Otherwise, if syntax is incorrect. Yeah, okay, let's see if this works. Right. Now we see starting. We don't want the result, that's afterwards, right? We just want the syntax. We don't really, right, at this moment, we don't want to actually do anything yet, right? This is just tokenization, basically. Let's see. No, we don't want that. Okay, so, we call it, we will call this function tokenizer. Yeah. Def tokenize string, raw string, right? And that's it, basically, right? So we want a list of, all right, so let's see what happens, right? I don't know if it's gonna work, right? I'm lazy, because I don't want to do this all by myself. It's probably, Copilot's probably not gonna do it for me. Yeah, but looks like decent, looks like a decent start, right? So we need to figure out some names. Looks okay. Come on. Where is my... Well, let's take a look. So, we have transitions. If you have start, right, digit integer, left parenthesis, right parenthesis. So, if you're in starting state, right, plus, minus, multiplication, division, right? White space, start. We ignore. So, these are the transitions, right? If you're integer, right, transitions, state integer. So you get a digit, you still stay at the integer, you have white space, you go to the start. Okay. If you get a left parenthesis, right, white space, you ignore, go to start. right, press white space start, right? Because you got the token, right? Plus, right? Yeah, those are all valid, right? Minus white space, right? And multiplication, white space, division, white space, right? On final state, this is what's gonna happen, right? Dictionary of parentheses, token values, right? On current state start, current token, right? Right. So how many states do we have here? Transitions. It looks decent. Final states, right? Current state. And so then you go through. And so this is basically okay. So is it digit? Card type is digit, right? If it's white space, again simple white space. Of course, we could add support for other white space card, of course, right? And else it's car, right? So we check that if it's not a valid transition, we raise an error, right? So only if it's not start, right, we add the token. Let's see how it will work. Looks decent. Looks pretty decent. Let's check. Let's get tokens for 5 plus 63, 67, 9,000. Let's see. Yeah, right? My tokens, right? Print. Let's see if this works. It should print it, right? Does it work? Yes, it works. Okay. Right? So, works perfectly, actually. But, of course, let's check on something harder, right? How about something more difficult, such as double parentheses? Right? Yeah, something like this. My tokens, right? Let's see. We'll raise an error. It should do it, right? It should print all that tokens, and let's do 50 here, right? 5, right? 505, right? 505 or 909. 505 is 409. 509. Let's see, 509. I want something divisible by 3, right? Because I'm dividing by 3. So 509 plus, yeah, 509 will 4 plus 509 will divide by 3, right? Okay, yeah. So let's see if this should be 509, right? I hope so, right? Let's take a look. Right? Am I correct? Yes, I am correct. Not always, but sometimes, right? So, and again, so this is something. So this is alternative approach to. So this is how you would have to do it if you didn't have regular expressions, right? You would have to build your own diagram, right? Something like this, and it gets quite complex. And then you end up with the tokens, right? Which you can then, parse. So this basically says if you have an example of bad, that this we should get if we pass badly formed grammar. Yeah, let's try this. Yeah, 2 plus val plus something plus 3. This should be error, right? Exit value error is e, and got an exception e. Let's try this, right? Oh, I didn't get anything. Aha. So let's see if I did it. So why this did not raise error, right? Plus val, right? So we got any character, right? If card type is char, right? So we have digit white space. Let's take a look how it worked. We have raw string. If it's digit, it's digit, right? If it's a space, it's a space. Otherwise, it's something else. So letters. Why did it work? I'm kind of curious. Why didn't we get an why didn't we get a... I know why. Because I think I used the wrong function. Tokenize FSM. Right. And then you see, and I was so happy. None. Aha. So this didn't work. Or actually it works. Right, and I was so happy. Yeah. Yeah. Okay. This is what I was looking for. Right, we were checking actually the wrong function. This is using the regular expression function. So let's check what you're running. Right. I was too happy. I got too happy too early. Right. So let's see what happens now. This is not gonna. Yeah, it should do something like this. Right. Let's see. Yeah. Okay. Space plus plus space 9. So why didn't say integer? 9,000, right? We got the tokens. Maybe a little bit this white space, right? Digit. It should use this chart type. Near appending current state. It seems to work, but it's not showing integer. Expect something like this, not this. Let's see, token value is token for token value in token. Let's see, in tokens, right? Token value. Could we skip this part here? Let me see if I'm going to see again. This happens. You should apply to. You depend too much on hallucinations. Let's see what happens if we do this. Basically, return tokens, basically. Let's see what happens if we return tokens, right? Tokens, right? Let's see what happens. I'm just curious. Yeah, this is much better, right? Integer plus integer 900. At least we have the states, right? We don't have a integer, right? It's valid, right? Right? It's still okay, but we have, of course, it's like we have the tokens, but we need to, of course, also, it's not fully finished because we need to get the integers together, right? Digits. These are really digits, not integers, really. But okay. So what happens here? Tokenize FSM. Yeah. Left parenthesis, right? Integer. It seems to work pretty well, right? So if I get some garbage, this should be garbage, right? Finally, I hope. Yes, finally, at V, right, we got the bad one. Okay, very good. Right, so now the question is, did we check for parentheses, right? I am not 100% sure. The matching parentheses, right? It tokenized, but it did not check value. To do, I'll add this to do. So, thing to do, check balance, right? Right. To do add digits should be combined in it. Okay, so these things to do. This is something to explore yourself. Try it yourself. Try modifying the code yourself. Maybe next semester, right? But something to do. Okay. So added simple tokenizer, this finite state machine. Right. All right. Let's go back to about the parsing, right? So assuming tokenization solved problem, right, which we already solved before, right now. Let's go back to our evaluation, right? We have our tokens, right? So this part here, right? It should be sort of familiar. The names used here. We have a parsing, right? Inside, we're using the ability of Python to have functions within functions, right? So, evaluation. So let's see this. What happens? So, we return evaluate tokens, right? So what happens first? We have our bunch of tokens, right? We first pass them to terms, see what are terms, and then those are actually factors, right? Because those are, of course, so you check if there are any factors, right? Remove parentheses, and then you evaluate. This is a parsing step, right? We keep check, right? If you remove one parenthesis, right? We do something, and then at the end you have to remove the other parenthesis eventually, right? so that it's possible you could fail here, right? If there is no other parentheses, right? You do something, right? So else result is float tokens block. So you either have parentheses or you don't, right? Right. So factoring, right? So term, right, which is multiplication on division, right? Again, not checking for 0, and then you have the addition, right? Are you guys all leaving already? No, only some of you. Only some of you. Okay, well, one few more minutes for this one here, then we can all finish today. Yeah. So let's see. 1 second. 1 second. Yeah. Okay. All right. All right. We'll finish very quickly, so we can everybody go to lunch. So let's see this syntax for the evaluation term on what would EBNF look like here. All right. So I'll call this EBNF. EBNF for checking syntax of arithmetic, right? This is sort of like your 40% of your grade, basically, right? So probably I should turn on, because I'm lazy, right? Can I turn on? Actually, let's see here. Right. So let me see here. How do I turn on this? Enable collections. So it should work. Let's write EBNF. Oh, it's not working. Yeah. So expression, right? Term, right? Factor, and is that it? And we have numbers, right? Number, right? A number, right? We need, of course, it's not finished, right? We have number. Digit, right? And we have digit. Yeah. So this is actually BNF, actually, right? Or is it EBNF? Okay, so let's see what's happening here. So expression is term, right? Possibly, so either plus or minus plus term, right? Term is factor times or division by factor. Factor is number, either number or parenthesis for expression, right? So which one is the hardest one here? I think this digit is, I think by now you should have digits, it's pretty easy to understand, right? Number is also easy to understand. It's digit, any digit, right? I would say we need, of course, non-zero digit, right? Number, we don't allow multiple digits, so a digit, non-zero digit, right? So let's do this more non-zero digit, right? Equals, right? I should do it. Yep. And then digit is what? We know already. This is 0. It's either digit is 0 or non-zero digit, right? Right? All right. It looks like we have to finish early today. So, non-zero digit, right? So number is non-zero digit, right? Or well, digit. How should we make this? It's either 0, right? Or possibly, right? So it's either 0 or non-zero digit. Non-zero digit. Now I think it looks better, right? I hope it looks correct now. So either 0 or non-zero digit followed by any number of other digits, right? So factor, term, expression, right? And look at this parenthesis. So this means 1 or more, right? I mean 0 or more, right? Optional. So in EBNF are used to, yeah, Okay. Yeah, 0 or more times. Okay. So this would be the syntax of your EBNF. So let's see, can we check it? Or we actually, let's finish actually. I'll leave this for you to do. Check the above syntax in a syntax EBNF tool. All right, in EBNF parser. All right, so how the work is done, right? You have decisions, we can start from top, right? Also, we can go from down, right? That will be a discussion for another time. Now, what are we going to do next time? Let's see if we have anything missing from this part here, from this discussion. Yeah, we'll do a semantics. We'll talk about semantics meaning on next week, and then we'll start with functional programming, actually on day 6. All right, any questions on the homework or anything we talked about today about parsing, tokenization? No, pretty easy, right? Yeah. So I look forward to seeing your fantastic languages, right? Yeah. All right, parser.